It's going to look really similar to an ellipse, but it's slightly different, and that one difference we'll talk about here. So for a hyperbola, the two different types are x minus h quantity squared over a squared minus y minus k quantity squared over b squared equal to 1, or x minus h squared over b squared. Sorry, I need to change that, sorry. I always forget with hyperbolas that on the second one the y comes first. Or it's y minus k quantity squared over a squared minus x minus h quantity squared over b squared equal to 1. Sorry about that. So with a hyperbola, there's still a center, just like there is with an ellipse. Like this looks very, very similar to an ellipse. The A and B do something different though. And then there's a few extra things about it that we'll talk about right now. So first of all, you know that the center is going to be at h comma k, just like for an ellipse or for a circle. The next thing that you know is that there are two things called the transverse axis and the conjugate axis. And the transverse axis is 2a. The conjugate axis is 2b. So far it's super similar to ellipses. Transverse conjugate, and then the next thing that we need to talk about are the asymptotes of the graph. And the asymptotes are at y is equal to plus or minus b over a. What else do we need? Oh, yeah, and then the foci. So to find foci, you're going to use c squared, and this is different, is equal to a squared plus b squared. So that's another difference from an ellipse. So far we have a few differences from ellipse. Here, here, and here. And also just like the terms that are being used, calling it transverse axis instead of major axis, and calling it conjugate axis instead of minor axis. So super similar to ellipses, like I said, like 15 times now. It's just that the minus, and so since you're subtracting, in one version, the x comes first and the y comes second. In the other version, since you're subtracting again, the y has to come first. You can't do it again as x minus h minus y minus k. It has to be y minus k minus x minus h.
How will you know which one it is?
Depends on if it's a horizontal or a vertical hyperbola.
Okay.
So,
Is that a plus?
yes. Sorry. Let me move it over so you can see it better. Aha. Okay, plus b squared. This one here is a horizontal hyperbola. Oh, sorry, wrong way. This one's vertical. Sorry. And this one's horizontal. Okay, so let's talk about what each of these things mean, what a hyperbola actually looks like. I've been thinking I would have already graphed this up. So if you imagine taking an ellipse, you've got all of these graphs of ellipses. We were to take this and then imagine splitting it so that the foci are no longer here and here, but on opposite ends of each other. If that makes any sense at all. So what you're going to do is you're going to take this half of the ellipse and move it over here, so that rather than having something like that right there, and something like that right there. That's what a hyperbola ends up looking like. And so it's almost like two parabolas that are like butting up next to each other. Yeah, they could be vertical though too. If they're
they just go on forever then?
Mm-hmm.
Oh.
If they're vertical, it would be this, and then you would have two foci for each of them, or unfoci for each of them.
So like the negative space makes it out of that?
Yeah. If you've ever seen pictures of a nuclear reactor, the cooling towers, those are built to be hyperbolas. So that's a shape, a place that you could see them in the real world. So if you're looking like a nuclear, like if you see like a nuclear plant, those big cement things with a weird shape that go like that. Those are cooling towers for a nuclear power plant, and that's hyperbolic.
How does it help the cooling tower?
It makes it stronger, because something that's that tall with concrete without necessarily having a lot of reinforcement isn't always strong. And the cooling tower needs to remain strong because, of course, it'll melt down.
Why are curves stronger than straight?
Because there's no, it's because that there's places for there's more surface area for one, for this force to be absorbed in. And then the other thing is that the curve allows there to be multiple points of reinforcement. So like, if you just had straight up and down, like any force that came directly on it or from the side would be absorbed in mostly at the bottom, or if it's coming from the side, it's being absorbed at a corner. Whereas if it's curved, force that's coming down is being absorbed all along the arch. The force that's coming from the side is being absorbed all along the arch as well. So there are more points that can reinforce it, which is why an arch is always stronger than just like a square. Does that make sense?
Yeah, I always felt like it has a place of collapse.
No, it's being reinforced. Liam?
Did Chernobyl have the arch towers?
Mm-hmm. The problem that happened with Chernobyl is they didn't have enough redundancies. Like most nuclear power plants that have been built since then have 7 or 8 redundant systems to keep cooling going.
Oh, okay.
Chernobyl had 2, I think, and something happened where they ended up losing both redundancies. That's the same thing that happened in Fukushima. In Fukushima, if there hadn't just been whatever it is, giant wave. What?
That was a long time ago.
Tsunami, yes.
Yes, yeah.
Okay. If there hadn't just been a tsunami, Fukushima wouldn't have.
Question everything I learned.
No, you were right.
I was like,
you were right. If there hadn't just been a tsunami, do you guys remember Fukushima?
yeah. That was like 8th grade.
If there hadn't just been a tsunami, because that knocked out 2 of their 4 systems, but then the power outage that resulted from the tsunami knocked out their other 2 systems. So, like if there hadn't been a tsunami, Fukushima probably wouldn't have melted down. So, yeah. Anyway, hyperbolas. So let's take a look at an example of an equation of a hyperbola, and let's talk about how you can find everything that you need to from it. And then this isn't too bad. I'm not going to go super in depth with hyperbolas, but yeah, don't know what I'm trying to say. Okay, so an example of a hyperbola would be x squared over 9 minus y squared over 16 equal to 1. Now you know that this is a hyperbola and not an ellipse because there is a subtraction sign between the x and the y. That is the only difference between the equation of a hyperbola and the equation of an ellipse when they're in standard form, is that it's subtracting between x and y.
And this one is horizontal?
Yes. Yeah, so what number is actually with x and y then? 0. If I asked what was the coefficient of x and y, it would be 1. But this I could rewrite to be x minus 0 quantity squared over 9 minus y minus 0 quantity squared over 16 equal to 1. And these two are equivalent to one another. So that means that the h and k are both 0.
And they're at 0, 0.
Yeah, the center is at 0, 0. So that's the first thing you can tell. Center is at 0, 0. The next thing that you can tell is that you can find the transverse and conjugate axis. So the transverse axis, bless you, transverse and then conjugate. Okay. The transverse axis is 2a. Yep. And the conjugate axis is 2b. It'd be 8. Because the square root of 16 is 4, right?
Wait, 2a. Where did you get
A in this case is not, a squared is 9.
Okay.
And so plane A is the square root of 9, which is 3. And then the transverse axis is 2a, so it's 6. Same thing with the conjugate axis. B would be the square root of 16, which is 4. And then the conjugate axis is 2 times B, so it's 8.
Conjugate is such a weird word.
Yeah, and it's used in both math and English. No, in,
Conjugate your verb.
yeah. No, that she's using it correctly. To conjugate a verb is to find the like, I ran, she runs, he runs, they run, he, she, it runs, like whatever.
No. She was totally cute. I saw her.
Who?
She's on my hair.
Oh, yeah, no, I know where she is. I know where she is.
Where'd she go?
Don't worry about it.
Concerned. I'll ask her.
And then the
Where you
asymptotes.
at? Where you at? Oh, you're like,
Bailey. The asymptotes are going to be at y is equal to plus or minus
6.
4 over 3. Because it's plane B and
okay.
plane A.
Okay.
And then the last thing is the foci. Yeah, so to find the foci, you're going to do that c squared, which is the focus, the distance to the focus squared, is a squared plus b squared, which is c squared equal to 9 plus 16. So c squared equals 25. So the distance to the focus c is just 5. And we'll find out what the points of the focus are in just a second when we create this. So what? Which part? B squared is 16. Plane B is the square root of 16. So when you're finding the distance to the focus, you use B squared. Is that what you're looking at? All right. So as far as creating this guy, your graphs don't have to be super exact because your calculator won't graph it, which is an issue.
Wait, I thought you said you were going to do this. Or is that something else we're not doing?
There's something else we're not doing. Sure.
Sideways.
Yeah, we're not doing sideways parabolas.
Parabolas.
We are doing this though. Your calculator won't graph sideways parabolas. Well, it will if you force it to, but there's a point that it still refuses, even if you force it. All right. So everybody got that? Can I put a graph up?
Sure.
Okay. So the first thing that I'm going to do is note where the center is. And the center is at 0, 0. The next thing I'm going to use is the transverse axis. The transverse axis is the distance from 0, 0 to the two vertices of this hyperbola. So the transverse axis is 6, or sorry, yeah.
Yes.
Well, 6 is like the whole distance.
Oh, so 3 and negative?
So 3 in one direction, and then negative 3 in the other. I'm not trying to
I'm not confused. Amber just being a little weirdo.
Okay.
So what's the transverse axis?
The transverse axis is the distance from the center to the vertex, or one of the vertices. So here is a vertex, and then this is A, which is the transverse axis. And so the distance between the two vertices is 2a, which is the entire length of the transverse axis.
Oh, so that's why it's only 3.
Yeah, instead of being 6, because the distance between these two is 2a.
Okay.
Now, the conjugate axis goes vertically, and the conjugate axis is going to be up 1, 2, 3, 4, and down 1, 2, 3, 4.
What does that do?
This allows you to find the asymptotes. Conjugate axis. The difference between the two is that the point at the end of the conjugate axis, it doesn't do anything. But it defines this box. And I'm going to draw in this box with a dashed lines. Oops.
It's a box? Yeah, I see a box. Oh, I see a box now. Box went a little longer than I thought it was gonna.
It did. I didn't mean for it to go that extra space.
Oh, no. I thought it was gonna be like just that one little section.
Okay.
Yeah.
So,
You didn't do anything.
all right. What are you missing? The transverse axis is the distance from the center to the one on the right.
Oh, it would be 3.
Yep. And so the whole transverse axis is what that 2 times a was, that's 6. The conjugate axis is up and down, so it's going from here to here, and here to here.
So you grab the center and then you grab the weirdness.
I'm not.
So
Where did you get the midpoints?
I got the 3 from the square root of 9, which is the number that's under x, because that's the left or right, because x is left or right.
Got it.
And then I got the 4 from the square root of 16,
Okay.
which is the up and down.
Got it. That
Okay.
makes sense.
And now I just drew it in as a box using a dashed line.
Got it.
Okay. Now the next thing that I'm going to do is I'm going to draw in the, so I've done the transverse axis, the conjugate axis. I'm going to draw in the asymptotes, which are y equals plus or minus 4/3. So if it's plus 4/3, that means that you would start at 0, go up 4, right 3, put a dot. 1, 2, 3, 4, 1, 2, 3, dot. And then I'm going to graph this again with another dashed line, because this is an asymptote. Whoa. Whoa.
That's the asymptote, you graphed it.
Yeah, so the asymptote, asymptote.
I love asymptotes.
Remember, it's a line that it approaches without, but never crossing.
Oh, okay, yes.
So this has 2 asymptotes, and the equations for those 2 asymptotes is y equals plus 4/3 and y equals negative 4/3. Negative. So I'm going to graph those 2 lines next. Yeah. So
Only on the upper right.
if I'm doing positive 4/3, Amber, that means that I would go up and then right, or down and then left, because down is negative and left is negative. Negative over negative is the same thing as positive over positive. Okay? And then for the other one, for the y equals negative 4/3, I would go up and left. Sorry, you're facing this way. Up and left, or I would go down and right. Remember? Algebra 1 in it? Kind of? Okay. Math on a Friday morning.
TGIF.
Yep. So, to get my, to graph this line right here, which I'm going to say is y is equal to positive 4/3, I went from 0, 0, because its y-intercept is 0. My rise was 4, my run was 3. Rise 4, run 3. I'm going to connect this with a dashed line. There is. Hyperbolas are weird.
I'm getting that feeling.
Yeah. It kind of reminds me of a hyperbole. Yeah, we actually already had this one. Did you get the hyperbole?
They have the same roots. They have the same roots.
What's the root?
Well, hyper, and then I don't know what the ball means. But hyper means extravagant or overextended or super. Okay.
Extravagant. This is pretty extravagant.
Now for the other one, for the y equals negative 4/3, I'm going to go up 4 and left 3. 1, 2, 3, 4, 1, 2, 3. And then this is y equals negative 4 over 3. Wahaha.
Wait, it's not negative 4, negative 3?
No, because if it's negative 4 over negative 3, then it's positive.
Why did you straight line on that?
Because I didn't mean to, because I made a mistake.
He's so
You're
you know,
fired.
one of those things the person had to draw this but it was really extravagant.
Because I was distracted, Morgan.
I'm sorry. Oh no. Mr. Tack.
Yeah.
I feel like maybe you should just start over.
Just start over.
Start over.
How about we finish this?
That like built one of the cooling things.
Mhm.
This, but like a lot of this was this paper that he had to turn into like this word drawing like a whole bunch of visualize. Like I'm trying to visualize the finished project. I feel like it's like
Yeah, well, yeah. Like if you look at a cooling plant for a cooling tower for a nuclear power plant, there are asymptotes it has, lines that it approaches but never crosses. The architect had to create those asymptotes, just like the
and it
architect.
goes
Like,
all the way around. I feel like there's a lot of math somebody had to do.
well, it's three-dimensional calculus.
That sounds ridiculous.
Anyway, so the next thing that we need to do here is we need to put where the foci are. So, the foci, if you remember, the distance to the focus is the C, which we found as being 5. Right? So, if the x comes first, like it does in this one, then you go right 5 or left 5 from the center. If the y comes first, then you go up 5 or down 5 from the center. In this case, the x comes first, so you're going to go right 5 from the center or left 5 from the center, and here's focus number 1, and here's focus number 2. It doesn't matter which you... Oh, thank you. So, let me make sure. 1, 2, 3, 4, 5. Okay, sorry.
Can you like draw a straight line through the other diagonal line? Because I just can't.
No. I'm not going to do that.
Like how many?
So 5 from the center. I moved 4 because I was confused.
It's okay. We all
Because I am an imperfect person.
human error. What does the foci do exactly?
So it's like the foci of a parabola. It's the point that every point on the hyperbola on either side is going to be equidistant from the foci and some other unknown directrix that I'm not making you find.
But question, okay, so if this thing goes on forever, how is it going to stay the same distance away? The whole
There's an unknown directrix that I haven't given, like I haven't had you guys find. I'm not going to make you find it. All right. So now, as far as graphing this goes, I do not need you to be exact. I just need you to draw it so that it is going to be this shape that is approaching the asymptotes but not crossing.
Oh, wow. Look at that. That's useful stuff. We drew those ones for you.
So you don't draw it from the foci, it's just...
No, you drop from the vertex. The foci is just there so that you know where the focus of it is.
That's a really good line.
I don't know if you're being sarcastic or not.
I was being honest.
So that's
So you did a good job.
what?
What? It looks like oh, what does it look like? With all of those other like lines.
Okay. So the box is here to show you where the transverse and the conjugate axis are. And because the box also helps you draw in the asymptotes, because this corner of the box and this corner of the box are going to be points on the 2 asymptotes. This part of the box is the vertex of this half of the hyperbola.
So that's what you start.
Yep, this part of the box is the vertex of the other part of the hyperbola. And then you've got the 2 foci, which sometimes are being used, but I don't want to get into exactly how they're used, but sometimes they can be used, because there's also an invisible 2 different directori, maybe, that I'm not having you graph.
Wait, okay.
Yes.
How do you decide if it's vertical or horizontal?
If x goes first, it's left and right. If y goes first, it's up and down.
Guys, just go on and
So it's just which one is first.
Right.
Okay?
There, right.
The number that's under x is always the distance left and right. The number that's under y is always the distance up and down, or the conjugate and transverse axes.
So that
Yeah.
one's vertical then?
Yeah, it's vertical because it's going, like, the hyperbola itself is going up and down. It doesn't have to do with where the vertices are. Does that make any sense at all?
Yeah.
No?
Not really.
Not a
but
little bit?
I'll just think of it as the opposite.
Okay.
Vertical looks horizontal. and
Think of it as the opposite then, sure. Vertical looks horizontal and horizontal looks vertical. No?
So it doesn't matter where they open?
It does. If the x comes first in the equation, like on the equation I gave you right here, if x comes first, then the vertices are left and right of the center, and the hyperbola is left and right, opening to the sides.
So then why do they call that a vertical? Wouldn't that technically be a horizontal hyperbola?
I would have to
The
find out to
lines
make
are
sure I'm not
going
making a
up and
mistake.
down. Because the lines are going up and down.
I'd have to make sure, Katie, so I will look into that so that I can come back to you with a better answer. So I don't have a good one right now.
Okay.
But I don't know.
I'm
Yes.
kind of
That goes
confused.
on to that. So does it matter like how far it opens? Because that was like when it's really stretched out. So if you shrunk it,
Yeah, if
twist it, would it be horizontal then?
no,
Or is that always gonna be vertical no matter how like?
if the x comes first, it's this way. If the x comes first, the hyperbola is open left and right, and if the y comes first, they open up and down. Does that answer your question?
Well, okay, so that is a vertical one, right?
Yeah.
But why?
I
Looks horizontal.
Katie just asked that. Yeah,
Okay.
and I said that I'm going to find a better reason.
That's right. Okay. Not. Okay.
I will find a better answer because I don't have a good one right now.
Okay.
Talk. Sorry?
Are we getting the wood chip?
I understand this more than the others.
Okay.
No, actually, no, I don't.
Okay.
Yeah, no, I don't.
All right, hold on. So let's go over part of your assignment and report. I'm sure that we're going to end up talking about this mostly on Monday too, just based on the fact that there are 2 people gone and when there's even a single person gone, slow down a bit. Currently, I'm planning on doing limits with you guys most of the May.
But like, there's like not any other
No. Yes. Yes, just a second. Actually, Sierra, plan on this being part of Monday's assignment too. So like we'll just continue this Monday in class. Yes.
would now be too early to get the assignments from May 1st to May 15th.
Yes. Because I always think we're going to go faster than we do. Like, if you even look at this week's, I had this plan of being yesterday's lesson. So, like, I have an idea of where we're going to be the first week in May, but we're already a day before where I thought it would be. So, it might be completely different. And then what might happen is I might, like, give the lecture for that thing, and then everybody's like, and then I change the assignment. Yeah. Okay, so
Well, one of your did you knows, could you make one of your did you knows the origin of opposite day? Simone and I are really curious on how it started.
the origin of what?
Opposite day.
A, B, C, D, E?
No, opposite day.
Oh, opposite day.
A, B, C, D.
Okay. I thought you said opposite day.
The opposite day.
I was like,
Is that our
Opposite
favorite
day.
day? Because we always talk about it, but it's never. So we decided today is not opposite day. It was like this one.
okay, so let's look at number 1 here.
Okay, see what I did there?
Okay, let's look at number 1. Because I'm sure everybody's going to have some questions. So x comes first. So in the way I gave you, it's vertical, but think of it as horizontal if you want to. And then your a squared is here, b squared is here. So first, you can find out what a is and what b is. The other thing you can find right away is what is the center, HK.
0,
0, 0. So your center is at 0, 0. Now, do the instructions say to find the center? Identify the vertices, foci, asymptotes, length of the transverse axis, length of the conjugate axis.
We have to graph it.
Yeah. Okay. So center's right here. Next thing that you're going to find is A, which is the square root of this number, which is 4. B is the square root of that number,
5.
which is 5. So you're going to go right 4, and left 4, and then up 5, and down 5. This is that box thing.
So the transverse is on the y-axis.
Transverse is on the x-axis. So the transverse axis is 8. And the conjugate axis is on the y-axis. The conjugate axis is 10.
The asymptote is plus or minus 5 over 8.
Yeah. Okay, what's your question?
Okay, wait, why did we draw, what's the box again, like,
I'm just drawing out the transverse and conjugate axis.
is that 5 up and 4 to the side on each side?
Yes.
Will A always be the horizontal
Yes.
one? Okay.
In this case, yes. Unlike with the ellipses. Okay, so transverse and conjugate. We can also find the equations of the asymptotes. So the asymptotes are going to be y equals plus or minus 4 over 5. X, forgot about the X. Yeah. Wait, 5 over 4, sorry. I am making all kinds of mistakes this morning, I'm sorry.
It is a tiny difference in what's that?
Those are the equations of the asymptotes. Yeah. We're going to go over this more on Monday, I'm sure. 0, negative 4, and 0, 4.
I just want to minus that 5 fourths in that.
5 fourths X, yeah.
What is the 5 fourths?
That's the B over A.
Where did the x come from?
The X was always supposed to be there, I just forgot to put it in the other.
Oh, okay.
Because I am making all kinds of mistakes this morning.
Okay, so
Katie,
what'd you say the vertices should be?
the vertices are at 0, 4, and 0, negative 4.
Wouldn't it be 4, 0, and negative 4, 0?
Thank you, yes.
Oh my god. Okay, so Miss.
You guys
Okay,
should
so
just
like on the
stop.
last one we did, we did like y equals plus or minus 4 over 3 minus x.
It's just times X, this isn't a minus.
Oh.
Oh, I see. So it's like an equation.
Yes,
Got it.
exactly what it is.
There it is.
Got it.
I'm gonna see how much more I can muddle in your minds. Alright. So
I heard that once you teach something wrong, it takes 7 times before you can teach it.
transverse axis. So the vertices, foci, so we need to find foci. Vertices, foci, asymptotes, length, transverse. Yes. So we found 5, we found 4 of the 5 things. Yeah. Okay, so we have found 4 things so far. There are 5 things you need to find and then graph it. The things we have found so far are the length of the transverse and the length of the conjugate axis, the equations of the asymptotes, the vertices. Now we need to find out what the foci are. Okay. Yeah. Radical 41 away from 0, 0. And what is radical 41 to the nearest decimal point? Yes?
I'm giving her a high five.
Oh! How you can tell it's radical 41? To find out what C is.
C squared equals 16 plus 25.
Absolutely.
Yes.
Which is 41 square root of 41.
Okay. Now 41 to the nearest decimal point is 6.4. 6.4. So you're gonna go 6.4 right. Right there. 6.4 left. Right there. Drawing the asymptotes. Yep. I think I know what you're asking, and the answer to that is yes. The asymptotes will always be crosses like this. They might be like crosses like that or crosses like that, but they're always going to be crosses.
I know that
Yes, yes. That's the point of putting in the box. The asymptotes always hit the corners of the box.
Okay, that makes sense. Why is my corner of this box on say like this?
Yeah, what the heck?
They're not lined up. I feel like you're across the box.
Well, don't.
I was like really intense, and it didn't work. Looks like there was an intense math problem down here.
Yes, the foci are radical 41 away from the center.
Ooh, look what I did. One thing, one that.
Yeah, you can just say that they're radical 41.
I did it. Yeah, there just looks like there's some intense math that happened here. Wait.
Approaching the asymptotes but never crossing.
So then,
Yeah.
when we find the foci
Mm-hmm.
and we put it in the coordinates,
Mm-hmm.
do you want us to put it as like 6.40 and make
That'd be fun. Okay, we're totally gonna continue working on this on Monday.
Yep. Oh, yay.
However,
Totes with a
only 4 of these are new. Okay? Which means that like 5 through 12? 16? 5 through 16 shouldn't be an issue. Right? Only the first 4 are new. So we can go over all 4 of them in class on Monday. But you can do the other 11 problems or 12 problems on your own. Okay? Yep. Yeah. Let me look at numbers. Yeah. It's right 3 left 3 and down 1. And then it's the X part is over. Is that what you meant?
like, yeah, that's the X.
Okay, I thought you meant this. Is it? Yeah. No, X part is over. Hold on. Okay. So what you're gonna do? And you know that it's going to what's Yeah, that's where for me, that's where it starts. Because that's usually we're gonna go over it all on Monday. No, we're gonna go over it all on Monday. Like it's.
Well, actually, I'm like,
So. Okay.
you can just copy my email. You can copy
May I refill my water?
Go ahead.
Thank you.
Yep. I have about half of them graded right now, and I was going to grade the rest this class period so you could see them this class period.
Did you grade mine?
I graded half of it.
Half of mine?
I graded the front page.
Oh, I thought you meant like half the classes.
Well, technically I've gotten like through like 3/4 because I graded everybody's front page, and now I'm grading the back pages.
Oh. Are we gonna have the thing from the textbook? An assignment?
No.
We don't need our textbooks?
No.
Okay.
Trevor?
none of that. Shame on you.
I've been up since like 5.
Okay. I've been up since 3:40 because I slept in.
Yeah. What does it smell like?
Fruit. I don't think it's you because I smelled it once since I walked
Hey, there we
in.
go.
Yeah, I don't think it is.
It's good gum. Good gum, 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 gum.
You can smell mine, but you have to.
Bentine ice.
I think I actually bought up when I was staying at your house. Do you know I cleaned your house seriously like 4 times?
Well, you shouldn't have. We cleaned it right before we left.
I don't know.
So how do you why did you clean so much?
Because I made popcorn and I got it all dirty.
When you not today.
You're a nerd.
We're just deciding we need to set up fun today.
Yes. And I was so first.
Alright. Quiet please guys. The arms on the board, you gotta find a measure of the missing angle.
Pick up. What up? Yep, man.
You can choose not to, so long as you're quiet, I won't bother you. Sign. Sorry.
I thought Clay was in this class.
He got out.
Why? He's like almost done with this course.
He was started.
Yeah. Today's did you know is that in some places in the world, they consider North America and South America the same continent. So like if you grow up in Portugal, they teach you about the 6 continents, not the 7.
That's cool.
So do you think somebody's did you know in some other continent was like, did you know?
That in some countries they do 7 continents instead of
Yeah.
half the American population.
I bet it's possible. Do you know anything in the world is possible?
The realm of possibility.
You're like, well, besides like the
Is
above
this
and
seriously
beyond.
all our warm up is?
Like jumping off
Don't complain.
a cliff
No, I'm
that's like
complaining.
a million
Like
feet
some,
up.
yeah, like somebody jumping off a cliff and surviving. There is a chance of that.
There have been so many people
That's
who
why you
survive
create
plane
damages,
crashes,
so if you
like even free falling
don't
from
survive
planes.
that shit.
Well,
Did you know
Have it
every
strapped around your
person
neck?
who's ever
Okay.
did
Bounce
like
is
rescue
like 5
after
feet away.
they jumped
You
off the San
crawl.
Francisco Bridge has said that they
Yes, you
figured
guys
out
want.
that everything
Finish your
they
test.
were gonna kill themselves over was solvable.
So, okay, an adult does not need to intervene in this problem.
So there's 360, isn't there?
For a 4-sided figure, yes.
See, with most people that jump off
Right.
cliffs to kill themselves.
and with skydiving, their parachute didn't come out.
Kyle, where's your woman?
I don't know.
Okay, how about you solve that problem?
Where'd you in the mall?
Well, I was
That's
planning
kind of
on
a weird
digging a
question.
giant hole in China in my backyard, but I haven't started yet.
That'd be pretty cool. Need help?
No.
Although highly impossible.
How do you plan on getting around the core? Or like,
Well,
95,
it's not the
isn't it?
core that's the issue, it's that if you were to dig a hole straight down any place in America,
80.
you would not
That
be
is
able to.
wrong.
Yeah, okay, how would you get around, combusting in the center of the earth?
I'm sure he'll figure it out.
China
Don't
is
worry.
not
I'm
on
just
like,
Or having your
dig straight through
flesh
the earth.
literally melt
You
off
don't go to
of you.
China.
What if somebody actually like tried digging to China?
I did when I was in first grade.
Me
We're
too.
in the northern
I dug a
hemisphere,
hole that was as tall as me.
which means, and so is China, which means that if we were to dig straight
I
through
went
the
to
earth,
North once,
we would
I
end
just
up
dug
in the
holes for
southern
the mall.
hemisphere.
Quick question: Would we hit any water?
No, Asia's in the northern
Because by the time I got down there, I'd be really thirsty and I wouldn't want to go back.
somewhere there.
By the time you get down there, you probably die.
Okay,
No,
so
possible.
Pressure.
if it's a 4-sided figure calculate, what is the sum of the interior angles?
360.
Great. So, to find out the missing angle, what would you need to do? And then do what?
Really?
Subtract it from 360.
Yep.
It's 195, isn't it?
Let's see.
I don't believe so.
90
bro.
plus 100 is 190.
I did something wrong there.
190 plus 85 is 275.
Oh, I subtracted wrong.
360
eh?
minus 275
Oh, yeah.
95.
85.
80.
How
Those
did
are
you
not
get
the same
195?
I got
No, they're
95.
not.
Oh, I thought you said 195.
No, I'm not that retarded.
So,
Well-
Mr. Taft,
Yeah.
speaking of giant
Then not a.
holes in Earth,
Mhm.
you know how there's in like Siberia, I think it is,
Okay.
where there's like that hole that like has keeps like making
Gotta
itself
be quicker
bigger
than that.
without man helping it.
Mhm.
What's up with that?
It has to do with the stop that.
Here, you can use it. You can use it.
It has to do with the structural instability of the bedrock there.
So is it like
My
how
elbow
deep
hurts.
does it go?
I don't know.
I'm getting it back.
No scientist
somewhere
has
in here.
tested that.
No, I'm sure they have. I just don't know.
You know you slept.
Well, no, it's just because I've heard that it's like
Caleb, so
something
we were
to
in the
do with the
van
gravity
last
of it or
I just
something, and
slammed
it's
my
like, what?
elbow
That
in the
makes
door.
no sense.
Mr.
Because
Taft.
then that would
It
technically
made
mean
the
you have a
weirdest
black hole
noise.
on Earth, which is like impossible.
Okay,
We don't have
so
a plastic star in our